Okay, so for question 10, we've been given a function h, which is defined by h of x is equal to the root x upon x minus 3, where h has its maximum possible domain. Now, we have to find the domain of h, giving our answer using set notation. So just looking at this, we know that x has to be either greater or equal to 0. It cannot be negative, as you cannot have a negative within a surd. Also, we know that x cannot be equal to 3, otherwise this denominator will be equal to 0, and rendering this function undefined. So if we know that that's the case, we can write this out fairly easily as x is such that x is greater than equal to 0, but also the fact that x is not equal to 3, hence solving this question. So in question 10b, Alice correctly calculates that h of 1 is equal to minus half and h of 4 is equal to 2. And she then argues that since there is a change of sign, there must be a value of x within the interval of 1 to 4 that gives hx is equal to 0. Now, we've been asked to explain the error in Alice's arguments. Well, the error can be traced back to part A, where we found the domain of h of x. So we had found that h of x does not exist for x is equal to 3, and so that makes it a non-continuous function. So essentially, because h of x is not continuous, or, you could specify there's a discontinuity at x, or h is equal to 3. This thus does not imply that there must necessarily be a root. So a likewise statement, something similar to that, would yield you the 2 marks. So for question 10c, we've been asked to consider whether h has an inverse or not by considering whether it has any turning points. So essentially what this question is asking us to do is find the value of x at which the turning point exists and assess whether or not that value of x is actually within the domain that we are considering. So if we go ahead and do that, we know that h of x is equal to root x upon x minus 3. So to differentiate this, we use the quotient rule, where h dash x would just be equal to x minus 3 times the differential of root x, which is just half times x to the power minus half. Take away just x to the power half times the differential of x minus 3, which is 1. So I'm just going to leave that be. The denominator thus would just be x minus 3 whole squared. Okay, so now that we have this, essentially we have to find the turning point, and that is essentially when this is equal to 0. So if we set this equal to 0, we know that the numerator has to be equal to 0. So I can go ahead and simplify this by saying that half times x minus 3 times x to the power minus half minus x to the power half is equal to 0. And I can write this out as 1 upon 2 root x times x minus 3 minus root x is equal to 0. If I times through by 2 root x, I get x minus 3 minus 2x is equal to 0, and thus x would be equal to minus 3. Now, this is not in our domain, so we can safely conclude that h does not have a turning point, not in domain, so no turning point. And also to consider whether h of x has an inverse or not, we also have to consider the sign change. So we know from part B that when x is greater than 3, h of x is greater than 0, and when x is less than 3, h of x is also less than 0. So because of these 2 points, we can conclude h of x is 1 to 1 and has an inverse, hence concluding this question.